Hello everyone, my name is Rahul Raj from B.Tech CS in Ramswarup Memorial University. My roll number is 008 of group 71. My presentation topic is metabolism. First we will know about what is metabolism. Metabolism is the term used to describe the interconversion of chemical compounds in the body. The pathways taken by individual molecules, the interrelationship and the mechanism that regulate the flow of metabolites through the pathways. It's formed mainly in three categories. First is catabolism, anabolism, and amphibolic pathways. First, we will know about what is anabolic pathways. Involved in the synthesis of larger and more complex compound from a smaller precursor. Example: synthesis of protein from amino acid and the synthesis of reserves of triacyl glycerol and glycogen. Anabolic pathways are endothermic. What is catabolic pathways? Involved in the breakdown of larger molecule, commonly involve oxidation reaction. They are exothermic, producing reducing equivalents and mainly with the respiratory chain. Amphibolic pathways occur at the crossroads of metabolism, acting as link between the anabolic and catabolic pathways. Examples: citric acid cycle. A 70 kg adult being require about 1920 and 2900 kilocalorie from metabolic fuel each day, depending on their physical activities. This energy requirement is made for carbohydrate 40% to 60%, lipids 30% to 40%, protein 10 to 15%, as well as alcohol. There is a constant requirement for metabolic fuels throughout the days. Most people consume their daily intake of metabolic fuels in 2 or 3 meals, so there is need to form reserves. Reserves of metabolism. First is carbohydrate, second is lipids, and third is labile protein. Carbohydrate glycogen in liver and muscle, lipids is triacylglycerol in adipose tissue. If the intake of metabolic fuel is consistently greater than energy expenditure, surplus is stored largely as triacylglycerol in adipose tissues, leading to the development of obesity. If the intake of metabolic fuel is consistently lower than energy expenditure, reserves of fat and carbohydrate and amino acid are used for energy yielding metabolism. This is led to the maximum wasting and eventually death. Carbohydrate metabolism. Glucose may also undergoes glycogenesis, synthesis of the storage polymer glycogen in skeletal muscles and liver. It may also enter pentose phosphate pathways, source of reducing equivalent for fatty and synthesis, ribose for nucleotide and nucleic acid synthesis, pyruvate and intermediates of the citric acid cycle, carbon skeleton for the synthesis of non-essential amino acid. Acetyl is a precursor of fatty acid and cholesterol. Steroid hormones synthesized in the body, glycogenesis. Process of synthesizing glucose from non-carbohydrate precursors such as lactate, amino acid, and glycocerol. Lipid metabolism, source of long-chain fatty acid, either dihydrolipid or de novo synthesis from acetyl CoA. Fatty acid may be either get oxidized by beta oxidation, esterified with glycerol, forming triacyl xylosirol, body's main fuel reserves. Lipid metabolism. Acetyls formed by beta oxidation of fatty acid may undergoes three fates: oxidized with the citric acid cycle, precursor of synthesis of cholesterol and other steroid. In the liver, it is used to form ketone bodies as it and 3 hydroxybutyrate, important fuel in prolonged fasting and starvation. Amino acid metabolism. Amino acid metabolism for metabolic intermediates and transmission using the amino group from other amino acid diamynation. Removal of amino nitrogen as urea view urea cycle. The carbon skeleton that remain after transmission oxidation with the citric acid cycle used to synthesize glucose from ketone bodies, which may be oxidized or used for synthesis of fatty acid. Amino acid may also be precursors of other compounds, reins and pyrimidines, hormones such as epinephrine and thyroxine, neurotransmitter. Thank you, everyone.